this is Henk Akkermans and this is Supply Chain Dynamics Chapter 7, Sysdea Gameplay 4, Allocation of Capacity. This gameplay is really about this tiny part of the model which really connects a number of other sections. It's really about calculating how much capacity is dedicated to one particular stage. We need that up here in the flow development work, where we have indeed development capacity up here, the capacity allocated to stage 1, and development stage also, capacity allocated to stage 2, and up here development stage is also capacity allocated to stage 3. And the way that this algorithm works is that it takes, well, it's usually called proportional allocation, or more popular, the squeaky wheel gets the oil. What it does is it takes the total amount of work to be done, all these tasks that still need to be done for a given amount of time, within a certain amount of time. And then it says, yeah, that fraction of the total work to be done, that has to be done in stage 1. That's the fraction that I allocate of the total capacity to stage 1. So in more formula terms, this is the total capacity available. All this underneath is the total amount of work that needs to be done, the task to be developed in stage 1 and 2 and 3, those 3 levels. And this is the amount of work to be done in stage 1. So you take the fraction of the total work and say that's what we do with the development capacity available. With a but, because the but is that if a stage has not yet started, and we have a boolean up there here, which you may recall from here, that says stage 2 started, yes, no. If that stage has not yet started, well, then we don't need any resources for that. So in this formula, you see that as long as stage 2 and stage 3 haven't started, really all the development capacity goes to stage 1, just as you would like it. In stage 2, the same story, but it then can also be stage. Well, there's a slightly more complicated story there, because of course stage 1 has already started, so we don't need booleans for stage 1 over there. So this then, this capacity allocated to stage 1 goes into here. And that way you see flexible flows. You can also see it up here from the graphs. First, most of it, all of it to capacity to stage 1. Then a sudden drop when almost everything is allocated to stage 2. As soon as stage 2 is started, because stage 1 is then almost completed. As you can also see in this graph, you see that by the time that stage 2 starts, stage 1 is almost completed. And then stage 3, which unfortunately can't be completed fully because there is no capacity left anymore. We still keep those tasks that need to be completed, but can't anymore because time's up and capacity is up. Let's see what that does with the base case behavior in this model then.